Hello, sixth graders. So the past couple days we've been talking about a certain way to display data by either making a frequency table or creating a histogram. So those are two ways to display data. Today we're going to learn another way that you can display data, and it's by drawing a box plot. So right now I'm on page 792 in your workbook if you would like to turn to that page. So the problem says Helen wants to display the lengths of 15 fish she caught. How can she use the data to make a box plot? So box plots are a little bit different than frequency tables and histograms. They actually look a lot different, but it's just another way that you can organize your data and display it so that it's really easy to read. So a box plot shows a distribution of data values on a number line. Is sometimes called a box and whisker plot, and you'll see why in a second. So this is all of our data. So box plots heavily rely on if you know how to find the median of data. So if we remember to topic 15, to find the median of data, you line up the data values from smallest to largest, and then slowly find which one is exactly in the middle. Okay, so that's how to find the median, and you need to remember how to find the median in order to find box plots. So the first step with all of this data, okay, step number 1, you're going to find the median, the minimum, and the maximum values of your data. So the median, again, you line them up from least to greatest. That's what we did with all that data here. You line them up. The minimum, obviously, is the smallest number, and the maximum is the largest number. And then the median you find in the middle by just crossing off the numbers until you get the exact middle. And again, if you don't get the exact middle, remember what we can do if we have 2, we average the numbers together. Okay, so that's the first step. Just find the minimum, maximum, and then the median. Pretty easy so far. Okay. Then you have 3 numbers right now. We have the minimum, the median, and then the maximum. Okay. The next step, so bear with me for this one. Now you're going to find the median for each half. Okay. So the minimum is a data value that you really need to know. The maximum is as well, and the median. Once you find those 3, then with this half of the data, right before your median that you found, you're going to find another median. So basically, this is the first half of the data before your median. You're just going to cross out the numbers until you find your median. So this is the median of the first half of data. And the second half of the data, again, same thing. This is the second half because it comes after your median. So first half, second half, and then you'll cross out the data until you find the median of the second half. Okay? Median of the first half and median of the second half. They have names. So the median of the first half is the first quartile. Okay? Pretty fancy name. Basically, it just means that is the median of the first half of data. Median of the second half of data is the third quartile. And you may be wondering, wait, first quartile, then third quartile? Well, the second quartile is the median, but we don't call it the second quartile. We just stick with, it's just the original median of the data. Okay? So let's recap. You line up all your data values. The minimum, you need to know what the smallest number is in your data. The maximum, you need to know what the maximum, the greatest number of your data is. And then the original median by crossing out the numbers and finding the middle. Then after you have those 3 numbers, you take all of the numbers that come before the median and find the median of the first half of data, and it's called the first quartile. Then you take all the data values that come after the median, and that's the second half of data, and you find the median by crossing it out and finding the middle, and that's called the third quartile. Okay, so at the end of all of this, you should have 1, 2, 3, 4, 5 numbers. Because remember, the second quartile is the same thing as the median. And right here it just says quartiles are values that divide a data set into 4 equal parts. Okay, so 5 numbers you should have. Now what you do with those 5 numbers? You draw the box plot. So it said a box plot shows a distribution of data values on a number line. Remember that definition right here. Okay, so all you do, you have a number line laid out like this. And the numbers on the number line depend on what your data is. If you have really high numbers, your number line is going to look different. Okay, so they graphed it from 6 to 23. The minimum they found was 7. So the smallest number, what you do, this right here is your box plot. Okay, and like I said earlier, sometimes it's called a box and whisker plot because these lines look like whiskers. Okay, that's why they call it sometimes a box and whisker plot. So you put a dot where the minimum of your data is, right above the minimum. So 7's the minimum, I put a dot there. You put a dot right above the maximum, okay? And then you put a line where your first quartile was. So we found the median of the first half was 10. Okay, so we put a line right above 10. You put a line where the original median of your data was, which was 13. And then you put a line where the median of your second half of data was, which was 15. And I like putting the lines there because then what I do, I just connect the lines and that makes my box. So I just made my box right here. First quartile, median, third quartile. And then what you do with the dots, you just draw a straight line from the box to the dots. So this is our completed box plot, okay? And basically it just organizes our data and we can easily see that a good chunk of our data is more towards the smaller numbers than the bigger numbers. You can easily see that. So right now I'm on page 793 in your workbook. So we talked about finding the minimum, the maximum, the median, and what all those lines and what this box plot looks like and what each one stands for. So we're just going to practice identifying, looking at a box plot. What does this dot mean? What does this dot mean? What does this end of the box mean? What does this end of the box mean? And so on. So the box plot displays data of home runs a major league player hit in 9 seasons. So part A, it says 6A, what is the maximum number of home runs the player hit for the seasons shown? So we can use this box plot to answer that information. So do you remember what stands for the maximum? Okay, this dot right here stands for the maximum. So the dot all the way to the right is always above the maximum number. So that would be 60. So 60, we'll just do HR for home runs, okay? This one says, the letter B, says, what is the minimum number of home runs? Well, if this dot's the maximum, then this dot stands for the minimum. And if we look right underneath of that, we see 25. So 25 home runs was the minimum. Okay. C, it says, what is the first quartile? Meaning, what is the median of the first half of data? So that's the beginning of this box right here. So this line is right above the number 40, right here. So 40 home runs is the median of the first half. The third quartile, okay, is not this line, but this line. Okay, the median of the second half of data, and it's right above. So this is first, this is third, and it's right above 55. So the third quartile is 55 home runs. And they don't ask, but the median is this line in the middle of your box, and the median is 45. So from this box plot, we are given the minimum, maximum, first quartile, third quartile, and the median. Okay, so what we're going to do today, we are going to practice identifying parts of a box plot. All right. So again, and in the next few days, we're going to be practicing actually how to find these. But today we're just going to start off nice and easy and just practice identifying the different parts of a box plot. All right. And if you notice too, they don't count by ones in their number line, like the example that we saw earlier. They count by fives, which makes sense because you make your number line based on what your minimum and your maximum are. Minimum's 25, maximum 60. I wouldn't want to do count by ones because that would be a really long number line. All right, so always look at your minimum and maximum to see how you're going to graph your number line. All right, and also we can tell from this data that the higher home runs are more common than the lower ones because most of our data is centered toward the higher numbers. We can see all of this is kind of more toward the right than to the left. Our box plot also tells us that as well. All right, so make sure you click on the Google form that is attached to the end of this video to kind of practice identifying different parts of box plots. Have a good day.